vacuum. What do you mean by vacuum? Vacuum in the sense no air. There is no air. Air is not present. That region we call it as vacuum. So in vacuum, the speed of sound or the sound propagation of the sound is cannot take place, or we can say that speed of sound is zero in vacuum. So how we can say this experiment? How we can say in vacuum speed of sound is zero or sound cannot travel through vacuum? So for this we can do this activity. Take one jar or please take one glass tumbler. Take your mobile and keep it inside the glass tumbler. Just give the ring. Just call this mobile. You can hear the ringtone. Now close this glass tumbler with your hand. Close the glass tumbler with the hand and try to suck the air present inside the glass. So here air is there, outside air is there. Now using your hand, close this glass tumbler and suck the air, remove the air which is present inside this glass tumbler. It is not possible for us to suck all the air which is present inside. For that purpose we are using vacuum pump to suck the air which is present. So using vacuum pump we can create a vacuum chamber here. We can suck all the air present, but try to suck the air. Just keep your hand like this and from the gaps of the fingers try to suck the air which is present in the glass tumbler. Now just give one miss call to the mobile. What you can observe, the sound of the ringtone reduces, that volume reduces. If there is no air inside this, we cannot hear that sound. So which shows that in the vacuum, if there is no air, sound cannot travel. The speed of sound is zero in vacuum. Sound needs a medium. It may be a solid medium or it may be a liquid medium, or it may be a gaseous medium. Sound travels through one of this medium, or in all three mediums sound travels. But if there is no medium, we cannot hear the sound. The speed of sound is zero. If there is no medium or in the vacuum, speed of sound is zero. For example, astronauts, if you want to speak on the surface of the moon, so in moon there is no atmosphere, there is no air. We cannot hear the sound because there is no air. The speed of sound is zero. It cannot travel. On the earth we have air here. So through that air, in the gaseous medium, sound travels. So sound needs a medium. It may be solid or it may be a liquid or it may be a gaseous medium. In vacuum, speed of sound is zero. Sound cannot travel through the vacuum. Vacuum in the sense we are removing all the air present inside that. That is called vacuum, or we call it as vacuum chamber. The speed is absolutely zero. Now I said sound travels in the solid, liquid or the gaseous medium. But in which medium speed is highest, the speed of sound is maximum? So when you hear this question, the first answer comes gas. But when you take the sound, usually when light travels, speed of the light is maximum in gaseous medium. But when you consider the sound, the speed of sound is maximum in the solid medium. It is highest in the solid medium. Next comes liquid and it is least, it is very less in the gaseous medium. In the gaseous medium, speed of sound is minimum. It is highest in the solid medium. This can be proved just by scratching the table. If you scratch the table, if you stand here and scratch the table, I cannot hear the sound of that scratching. But if I listen that scratching sound in another end of the table, so sound travels through the solid medium there. I can hear that scratching sound loudly. I can hear that sound because when I hear that scratching sound from another end of the table, so that is the solid medium, sound travels through the solid. But when I scratch the table and if I stand here and if I listen is maximum in the solid medium. Next comes the liquid and it is least in the gaseous medium. But the thing is, sound needs a medium. Medium is very important for the transfer of energy. For the propagation of sound energy, medium is very important. If there is no medium, speed of the sound is zero. In vacuum, speed of the sound is zero. Sound cannot travel through in vacuum. It needs either a solid, it travels in the solid medium, it travels in the liquid medium, as well as it travels in the gaseous medium. But in vacuum, its speed is zero. So we have studied that sound is produced by the vibration of object. These vibrations travel in all the direction through the medium. So these vibrations, how we can identify these vibrations or how we can identify the sound? So which part help us to receive these vibrations? So as you know, we have a special structure in our body that is called, that is our ear. So if our ear is proper, we can hear any sound, we can identify the sound. So how this ear works, or what is the structure of ear? How we identify the sound? Let us study about that. So our ear is like the shape of funnel. It is the shape of the funnel, and this outer surface of the ear, we call it as pinna of the ear. So the sound travels through this pinna. It travels through a canal. It travels through this canal. At the end of the canal, there is a structure. We call it as eardrum. So this is eardrum. So this eardrum is like a rubber sheet. It is like a stretched rubber sheet. When the vibration reaches this eardrum, these vibrations makes eardrum to move forward as well as backward. When the vibrations reaches the eardrum, they make this eardrum to move forward and backward. That is nothing but eardrum vibrates. Eardrum also starts vibrating. So this eardrum vibrates. These vibrations from the eardrum, it is sent, it goes to the inner part of the ear. So in the inner part of the ear, there is a structure which is not given in your textbook, that is called cochlea. In the inner part of the ear, there is a structure called a cochlea. That is, this cochlea converts, these vibrations are sent to the cochlea. This cochlea converts these sound vibrations into electrical signals. So these electrical signals, the converted sound vibrations into electrical signals, finally it goes to the brain. It is sent to the brain by these nerves. It is called as auditory nerve. It is sent to the brain through the nerve. So finally, brain interprets that sound and it gives the message. It sends the message. So this is the sound of a boy. This is the sound of a girl. Or this is the sound of your social teacher. This is the voice of your English teacher. So the final results we get from the brain. So this is the structure of the ear. So pinna of the ear in the beginning collects the sound. That sound vibrations travel through this canal. At the end of the canal, usually this ear is made into three parts: outer ear, middle ear and inner ear. So about that it is not given in your textbook. Just sound signals of the vibrations travel through the canal. At the end of the canal there is a membrane called eardrum. So this is like a stretched rubber sheet. It is like a stretched rubber sheet. When the vibrations reaches this eardrum, eardrum starts vibrating. In a sense, it moves backward as well as forward. These vibrations are then sent to the inner ear. The cochlea also not mentioned in the textbook. It is given these vibrations. These vibrations reaches the inner ear. Inner ear converts these sound vibrations into electrical signals. These electrical signals these electrical signals are then sent to the brain by this nerve. It is called the auditory nerve, and finally brain interprets this message and it sends the signal. It gives the message for us that actually what that sound is. That is human ear. If our ear is proper, we can identify any sound. So if I take this model, so this is pinna of the ear. This is a pinna of the ear, outer surface. Through this sound signals or the vibrations passes through the canal. So at the end of the canal, you can see here one of the pink part. So this part is called eardrum. So when the vibration reaches this eardrum vibrates. These vibrations are then sent to the inner ear here. That is, this part is called cochlea, which converts these sound signals, sound vibrations into electrical signals. These electrical signals are then sent to the brain through the nerve. This nerve, it is called auditory nerve. Through this nerve, it is sent to the brain, and finally brain interprets the actual sound. It converts these signals and it sends the message for us that this is the what actually that sound is. In this way, our human ear works so that it can identify variety of sounds. So we have studied vibration of object produces sound, and this sound travels through the medium and it reaches our eyes. It reaches our ear and we can hear the sound. But how we can differentiate these sounds? How we can differentiate? This is the sound of boy or this is the sound of girl. So there are characteristics of sound. So based on these characteristics, we can differentiate the sound, like louder sound, soft sound. This is the weak sound, or this is the high pitch sound. This is low pitch sound. So there are characteristics of sound, namely amplitude and frequency. These are the main two characteristics of sound, so that we can differentiate one sound from another sound. As I said, vibration is nothing but it is to and fro motion. In the same way, this to and fro motion is also called oscillatory motion. It is also called oscillation. You might have studied in your 7th standard about this oscillation, about the oscillatory motion. So what do you mean by oscillation? If you tie a metallic bob, with a string and connect this bob to a metallic plate or any support, we call this as a simple pendulum. So this pendulum oscillates. How it oscillates? If you pull this pendulum towards one direction, and if you leave that, so this pendulum starts moving. It moves front and back, to and fro. This motion is also called the oscillatory motion, but this is not a vibration. Vibration is also to and fro motion. Oscillation is also to and fro motion. But what is the difference between oscillatory motion and vibration? So vibration takes place at a faster rate. It is very fast vibration. But when you consider oscillatory motion, oscillations are slow when you compare the vibrations. But both are to and fro motions only. So when you start moving this bob, consider this is the original position of the bob. So this position we call it as mean position. It is the rest position, which is the mean position. When you give the movement for this bob moves. Either it comes to this position, or it may come to this position, or it may come to this position. If you pull the bob